You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session. First and foremost, I want to welcome everybody and our guests here today on the 5 critical elements to consider when machining aluminum castings. Let's go ahead and introduce our 2 guests today. Tim Weber, he's the bicycle enthusiast, and he's back for a 5th time here. And then we have Jim Whitaker. So a lot of you hopping on from Texas. Jim actually just got back from a fishing trip down there where they caught over 1,000 fish. Right, Jim?
Yeah.
You've been machining a long time. How many years have you been machining casting?
30 years.
Is that right?
Yep.
Wow.
Well, actually, I went through a program through high school. I signed up, and when I graduated, I started.
Man.
Actually, the next day.
Is that right?
Yeah.
Jeez, Pete.
So a lot of experience from both these guys here in the machining and the casting industry. With that, I'll go ahead and hand it over to you guys.
How critical is the material condition, the heat treat part of it? Walk through that a little bit.
Yeah, for us, when we get the casting down, we need the casting to be straight, check for flatness, certain flashes.
But some parts run through here unheat treated, some run through T6, some through T5. What's the difference?
Yeah, the difference is 356 cast aluminum unheat treated. Guys say, well, this thing kind of machine's gummy, which it kind of does. And it might change a little bit of your choices of tooling, because when you cut it, you might not see that shiny look like you would machining a piece of billet, 6061. Now, there's a cost associated going to T6. It's kind of my favorite.
Right. Because why? What happens with T6? What's it look like?
It's a darker color. It's actually a lot stronger.
Right.
But the machining, the thread quality, the finish, surface finishes, they're just easier to achieve.
So you in the past have talked about chips. I'm assuming if it's gummy, it's not chips. Tell me about that.
Well, it is chips, and it kind of comes off more like you would think is like a tearing effect.
Okay.
But there's a lot of good tooling out there that when we got to do something that isn't heat treated, PCD diamond, maybe roll form threading. Right. Instead of cut tap threading. There's methods for cutting it, no doubt, because the customer might not want to.
There's some parts that can't be heat treated because they just turn into a pretzel, there's no doubt about that.
Yeah, the physical strength or the structure of the part definitely becomes a trick for heat treat.
Tim, actually, before you go forward there, so I had a really good question come in from Rachel. So if a part's slightly warped before T6 heat treat, is it still machinable? And if so, what are some options or routes that you go through? Sorry, I said Tim, like Jim to answer this. How do you go about fixing that? And if it's not, how do you go about preventing that going forward?
Yeah, it's a real good question, actually, because, Tim had mentioned about, when you go to heat treat, you got to be careful because you do risk more of a warpage, or, we've even paid for heat treating to go through a straightening process. If it's a T6 part, it probably has to go back to the heat treater to be annealed, and then the straightness worked out, because you can't hardly move it once it's T6'd. I mean, you take the chance of cracking it. Yeah. If it's a T5, you can still bring that casting right back to form.
Well, I'm sure when you're mounting it up to the machine, there's ways around mounting a T6 and getting it into the shape that you want it to machine it. But ultimately, what you're going to see when you pull it off the machine is that part's going to flex back. And you may have got the machining right, but the part still isn't hitting the end function and features.
Yeah, you're just chasing your tail because it's not going to meet the print. Obviously, if you clamp it and you think you got it all clamped up and the machine's fine, when you release it, then it's just going to twang right out of spec.
Something I was just thinking about. So when you're machining it, do you ever release tensions? And let's say it comes in dead nuts, square. You machine it. Does it release tensions? Does it move sometimes after you machine it?
Sure. We try to use the 3.1 system as the gospel for datum system.
Which is what?
Well, you got a plane. We use a plane. We use a 3-point system. And then we got 2 points, which is the B. And then you got a C point. And if you can hold a part pretty neutral when you're machining it, even if you want to qualify the part before the next operations, then you'll probably have a success story. So, you can't clamp it in a distorted fashion and then expect to have a good part at the end of the day.
So the key is to bring that part in, the casting in, ready to go. So
yeah.
I know you guys trade back and forth with the foundry, straightening fixtures or templates that you can see if it is square.
If you're going to take it casting right out of the mold and not do any kind of heat treatment to it at all, you might take a chance if it's kind of a thicker part and a bigger part, where once you get done machining it, you'll see that thing kind of stress relieve. We use a T5 a lot to stress relieve it. Cost is less than T6. Plus, when you get done machining it, it doesn't want to release those, twangs on you, if you want to call it that, distortions.
Let's see. Let's go on to the coolant cutters, because that seems like a natural moving forward.
Yeah, coolant's a big thing. You think you can just buy it and, get your machine filled up and ready to rock and roll, but we do coolant maintenance. We found a coolant we really like, but we checked it every morning for bacteria growth and any fungal growth that would be in the sump. And we did that for about 3 months, and we found that our coolant was good and stable. The lubricant you use to machine cast, I've been through a lot of them. There's synthetics, semi-synthetics, microemulsion coolants, stuff like that. And my favorite's the microemulsion coolants. It kind of takes and it will actually mix tramp oil in with it and use it for the machining purpose. And it works well on a cast aluminum.
Your machine shop only machines aluminum, a little bit of zinc. Coolant at a machine shop that does, let's say they do brass or bronze and steels, irons.
Mm-hmm.
What about other shops? I mean, are they use more of a universal type of thing, or what's
there's so many coolants out there, and a lot of good coolants too. It's finding the right one, and it's the one that's friendly to your guys on the floor too. Dermatitis. I had one issue, and there was no coolant that just worked with him. He was, fair-skinned and, allergic to coolant. So I found this one coolant. It controls the bacteria growth, because there's an aerobic and an anaerobic bacteria can grow in your coolant that can cause your guys to have dermatitis. We do supply latex gloves. The guys want to slip some latex on, their hands are in it all day long.
So ultimately, your goal with the coolant, it's going to aid in, machine life, your tool life, hitting the quality on the parts, but you're even talking about it from a perspective of employee protection.
Oh yeah, it's probably one of the biggest things. You can get a 1 year sump life out of it, and you want to dispose of it, then that becomes another issue. Is how do I get rid of my coolant that's old? Or you come in over the weekend, it's, your sumps have set all weekend. The shop smells, because the odor, if you smell a bad odor, it's growing bacteria.
And what's the function of the coolant is what?
It's a lubricant. It's got the lubricity in it for the cutting tools.
When you immerse it, I mean, it's flowing when you guys are machining.
Yeah, we do. We get 1,000 PSI through the spindle coolant. Any deep hole drilling we do, delivers coolant to the tip of the drill.
Talk about the cutters and the type of tooling you use within the machining center.
Yeah, when we do turning work, we use PCD. We do some PCD and milling.
What's PCD?
It's a polycrystalline diamond tip that's brazed in. It's a little bit more expensive than your standard carbide end mill, but you'll get 10 times the distance out of it.
All over the years, you play with different types of cutters, different types of coolant. Mm-hmm. And my question, I guess, is were these married? This is the combination that works best.
Yeah. I've had some coolants in where, the drums were a lot cheaper. And it's a big deal to try coolant out. If you got a coolant you like and you got to try another one out, to be fair to the coolant, it takes a full drain of the sump. and you gotta clean it top and bottom, get the new coolant in it and try it. And I've had it really not tap the first hole. I mean, I shut it down within 1 hour. That coolant wasn't going to machine that part. So I lost probably over a day's production
on that one machine
trying to get that coolant back out. And then the guys like, we got something different. And, this trial and error, I'm sure there's a lot of guys out there that's experienced this, can cost you a lot of, production. So if you pay a little bit more for it, don't be afraid to.
Piece of mind.
If it works for you.
Yep. All right, fixtures. Building them, making them, operate, different ops, different supports.
Yep. And even before you start just looking at, the machining of holes and slots and stuff, that you start looking at how am I going to hold this part? So you look at the operations and the strategy. We always try to get in one operation. I found that sometimes it's just best to do one operation, get as much done as you can, maybe qualify it up for the next operation. We're in the horizontal machining world now, so we can do a lot. Basically, that's the biggest strategy, is the nature of the beast on how you're going to hold it and datum it and clamp it. And you might have to put your best foot forward. And then if you got areas that aren't supported, then you can buy some work supports. And what those things do is they're pretty neutral. You collapse them down, get your part clamped up, and then you fire these things off. They're spring loaded and they come up, hit the part, and then you lock them down, and you can add extra clamping to help stabilize the part so you don't get chatters and stuff like that.
So a knob for you is you put it into a fixture, and you can do all kinds of different tools on it. You can cut, you can drill, tap, all those different. So the amount of tools doesn't matter. The next stop is when you take it off of that and put it on again on something else, another fixture or whatever. Is that what you're saying?
Yeah. The difference between the ops. What's nice about the second op is you've kind of qualified the part using the 3-2-1 datum system I was talking about. The part should be flat.
All right, speeds and feeds. So this determines cost, I'm guessing, right?
Yeah.
Tell me how you talk about programming, checking stuff out, how much material you're removing, how consistent the casting is going to be, how you find the casting, those kind of things.
It's cycle reduction is our target. We got methods of taking little GoPros, mounting them in the machine.
My GoPro.
Your GoPro.
My GoPro for my bicycle.
Tim's a GoPro. And we actually video the cycle. What it allows you to do is kind of go back to your computer, download. It may just be tweaking speeds and feeds. The biggest benefit that's happened to us was robotic sawing. The early days where there was no robots, they all sawed the part different. So one guy might be real close to the part, and then the other guy might leave a 1 inch. Well, the machine doesn't know that. Well, the robotic sawing was our biggest improvement for cycle time reduction. It just let us take that cut right to engagement.
I've been down your office when you're programming, and you do a simulation on the program.
Yeah, we do a full assembly program. When I say assembly is we have the tombstone, the fixtures mounted on it, and all the clamping, so we can tell if there's any tool interference. The simulation of it is as real as being in the machine.
When do you start designing the fixture? When do you build the program? At what point? What stage of the process?
It's in the quoting. I mean, as soon as I get, Tim brings a job in and he says, hey, what do you think of this? It's like day one, it's.
So you don't wait for the casting?
No.
So do you take the model, the solid model?
Yeah.
Okay.
Yeah.
Brian here asked a very good question. He said when machining steel, certain sounds and vibrations translate to changing up the speeds and feeds. For aluminum, are there some sounds or vibrations that you look for when you change speed and feed?
That chattery, raise the hair on your arm kind of sound, just it's not going to look good when it's done.
Yeah, I've been down there and them things scream.
Yeah.
I mean, that's an audio, like an ergonomic thing. You just can't even. That takes us to the next subject, which is real quick, which is, the whole idea of ergonomics and that type of consideration. You guys have kickoff meetings.
Mm-hmm.
And ergonomics there's somebody sitting in that room who's talking ergonomics straight. That's all their issue is.
Yep. Yeah. We go through the ergonomics of the handling and the shipping, noise monitoring to make sure that everybody's hearing's good, coolant, dermatitis, handling the part. When the part gets so big, we have some cranes that are pretty cool. They're a zero gravity crane. They're using kind of two things for handling parts, especially if anybody's worked around a lathe and you got a big old heavy part you got to put in the chuck that's very, you can't ding it up or whatnot. This zero gravity crane, you can pick this part up and it weighs the part. And once you push the button and weighs the part, you can take it by hand and actually just move it free floating anywhere you want to move it. That's one of our biggest things we look at with a project too is, ergonomics is on our checklist.
So you get this great casting in, weighs about 10 pounds. You get done machining it, weighs 8 or 9 pounds. What do you do with the all-fall? What do you do with that? Does that just take it back and throw it in the foundry?
Well, if it's a casting that was, scrapped in-house, then it goes back to the foundry. That's a pretty scary thing. You take a casting that, if you throw a casting back into that aluminum furnace that's got condensation or moisture in the holes, it could blow that whole 2,500 pounds of aluminum out of that pot. So chips are recycled from outside vendor. We have chip conveyors on all our machines that capture all the chips. We have a company that supplies us with totes, and we fill them things up like crazy.
So aluminum is 100% recyclable all the time. I was just watching a video, a presentation, and as long as it's clean, they can just keep recycling it. Make it into a part has life, throw it back and start it all over again. That's pretty amazing.
Yeah.
I think you guys had a lot of really colorful insight today. Really appreciate you both taking time out of your day. Thanks, guys. Have a great day. You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. Be on the lookout for our next casting class on the first Wednesday of every month. Until then, you can find more resources like videos, written guides, and case studies on our website, batesvilleproducts.com. That's batesvilleproducts.com. See you next month.